So upon further inspection, let's say that it is found that the temperature in Celsius with respect to pressure in pascals of the machine is better modeled by the equation T of P equals P squared. And it is desired that the machine run at a temperature still of 25 plus or minus 0.01 degrees Celsius. But now with this new model, what range of pressure will guarantee the machine's temperature stays in this range? So same question as before, but now my function has changed. Um, so I still want that. Let's do this in absolute values. I want that the difference between the temperature and 25 degrees Celsius to be less than or equal to 0.1. That would give me, that's the same as saying this statement here. But then what is T now? This is telling me that P squared minus 25 has to be less than or equal to 0.1. And I can factor this. This is a difference of squares. So this tells me that P minus 5 times P plus 5 needs to be less than or equal to 0.1. And just like before, we know that, that 25, and we could have solved it, that 25 is equal to T of 5, right, which is 5 squared. So here is exactly what we want the pressure to be. We want the pressure to be with, well, the difference between pressure. So we want pressure to be 5 plus or minus whatever error is allowed in our range. So we know that P minus 5 will be, well, as long as it's less than delta, and we'll have to figure out the delta that will make this statement true. But unlike in the other example where I had a constant, I could just divide by it, I've got another function here. I've got P plus 5. And I don't know what that is, but I can make a wild kind of, I can get a kind of a, how do I say it? I can get kind of a bound on this. So let's assume that the pressure is within at least 1 Pascal of 5. Let me write this right. So it's so the difference between the pressure and 5 is, say, going to be less than 1. I'm just going to make this assumption that because I've got control of the pressure and it's going to be low, and I can see what happens when I assume that it's within at least 1 Pascal of 5 pascals. So what is this telling me? Well, this tells me that -1 is less than or equal to P minus 5 is less than or equal to 1. I guess I'll put equal there. And I could solve for P here by adding 5 to both sides. So I get that 4 is less than or equal to P is less than or equal to 6. And I want to know something. Remember why I did all this. I want to know something about P plus 5. So if I added 5 all the way across, I would get that 9 is less than or equal to P plus 5 is less than or equal to 11. And now, since P plus 5 is less than or equal to 11, then the absolute value of P plus 5, which is positive, has to be less than or equal to 11. So with this assumption, so hopefully this is going to be true, that my pressure is going to be bigger than 4 and less than 6, right? 5 plus or minus 1. But as long as my pressure is within that, then P plus 5 is less than 11. And so I can come back and kind of revisit this. I know then that if this is true, if P minus 5 is less than 1, then I know that P minus 5 times P plus 5 has got to be less than, well, because this guy is less than 11. It's going to be less than 11 times p minus 5. And I want that to be less than or equal to 0.1. So as long as I make sure that my p minus 5 is less than 1/10 divided by 11, so that's 1 over 110, which is approximately, what is that, 0.009. So, and sure enough, 0.09 is definitely less than 1. So as long as p minus 5 is less than 0.09, then p minus 5 is clearly less than 1. And p plus 5 is less than 11. And I get this statement here. So what am I saying? Well, as long as p, so if my pressure is equal to 5 pascals plus or minus 0.009, then the temperature will be 25 degrees Celsius plus or minus 0.1 degrees Celsius. Right, so I kind of looked at what I wanted. So let's just take a gander at what we did. I wanted this to be true. I wanted the temperature to be within 0.1 or 1/10 of 25 degrees Celsius. I wanted that. Well, I rewrote it in terms of P because I want to get a handle on my pressure. So I rewrote the expression in terms of P, and in this case, I factored it. Now, factoring it left me with two equations. The P minus 5 is the equation I've got some handle on because I know that P is going to be 5 plus or minus some air. P plus 5, I don't know. Right? This is P is equal to negative 5 plus or minus some air. I don't know what that is, but I just make a assumption and cross my fingers in hopes that it worked. I chose 1 because 1's awfully easy to work with. As soon as I did that, that gave me, I was able to manipulate this to give me a handle on P plus 5, that it has to be back less than or equal to 11. Then going back to the original equation, so remember, this is just the same as T minus 25. These two are exactly the same. So T minus 25 looks like the factored form P minus 5 times P plus 5, which if I make this assumption that the pressure is within 1 of 5, then P plus 5 is less than 11, and I get this statement. And I wanted it to be less than 0.1, so then I divide both sides by 11, getting 0.09. And so my pressure has to be 5 plus or minus 0.009. If that's true, then the temperature will be within 1/10 of 25 degrees Celsius.